Dear students, we'll be seeing about the second part of Unit 5. So today's agenda is control and supervisory level of automation, and you will be learning about PLC, programmable logic controller, and real-time control system. So first we'll be seeing about the control and supervisory level of automation here. So this SCADA consists of five layers, and it is mainly used for industrial automation. It ranges from enterprise management level, and you can also have various enterprise levels for these particular automation pyramid. So first of all, we'll see what is meant by sensors and actuators, how this particular devices is linked with the field level, and you will be understanding about the supervisory level in SCADA. The thing is, the structure ensures the seamless communication between production to various operations in industrial IoT. So the thing is, the first five layer of automation pyramid represents the hierarchy of systems used in industrial automation. So at this base level, we have field level, which includes sensors and actuators interacting with the physical equipment. So this control level consists of PLCs, and it consists of DCS. DCS is known as distributed control system. So that manage real-time mission control. Whereas in supervisory level we have SCADA, that we call as supervisory control and data acquisition systems. So which operate on real-time monitoring, and it makes control on industrial processes. So the thing is, here you will be focusing on process control, and you will be focusing on manufacturing execution systems. We call it as MECS. So during the planning and execution level, it manages production operations, and it also manages scheduling and quality control. So at the top of the enterprise level, we have ERP, where we call it as enterprise resource planning systems, which handle company-wide business functions like finance and inventory. So this structure ensures seamless communication between production and enterprise management for optimized operations. So next, you will be learning about automation pyramid. So it is considered to be a structured model where it is used to describe the hierarchy of automation systems. So here in automation pyramid levels, you have five different levels. So that we'll be seeing in the next slide. So here you will be learning about the structure model, which is used to describe the hierarchy of automation systems. And this particular levels, or each level determines the pyramid, which where it interacts with the others to ensure the efficient data flow. And it also provides operational control, and it also helps manufacturers to optimize both production and business functions. So these are the five different levels of automation pyramid. So first level, it's nothing but it's the field level. The second we call it as control level. Third is supervisory level. Next we have execution or planning level, and the final level we call it as enterprise level. So the enterprise level we call it as management level L4, and the execution level we call it as planning level L3, and in supervisory level we call that level as L2, where it is mainly used for SCADA, and in level 4 we call that as execution or planning level, and level 2 we call it as control level, and level 1 we call it as field level. So field level is represented as L0, where we focus on the production process, and control level we focus on PLCs, so that is represented as L1. So when you consider the lowest level field level, it is the base of the pyramid. So it comprises of all sensors and actuators, and that interact with other machinery and devices which collects data and it is used for controlling the processes. So moving on to the second control level, so here we will be using PLCs, that is called as programmable logic controllers, and DCS, distributed control systems, and that manage real-time mission control and automation. So in supervisory level, SCADA represents real-time monitoring, and it controls the production processes. So this in this particular level, we have a visual interface which is used for operators to manage all these operations. And in the fourth level, we'll be learning about, or you will be handling the production schedules by using MES, that is Manufacturing Execution Systems. So MES resides in this layer, and management production schedules are managed, and it keeps track of material tracking, quality control, and it also bridges the gap between the shop floor and higher level business systems. So moving on to the next level, it's the enterprise level. So the top of the pyramid, we have ERP, that is Enterprise Resource Planning Systems. So this system, it operates or it oversees the entire business operation, which includes finance, inventory, and supply chain management. So already I have told you all the levels. So initially field level is L0, control level is represented as L1, supervisory level is represented as L2, planning level is represented as L3, and management level is represented as L4. So these are the automation pyramid. So when you consider level 4 in the automation pyramid, it can be used along via with the MES. So it operates and it manages and optimizes production processes in real time. Mainly it is used for quality control, and this particular layer acts as a link between the shop floor and the enterprise systems, and it integrates lower levels such as SCADA and PLCs, and it ensures the production aligns with the border business tools. When you consider this layer is essential for improving operational efficiency, ensuring seamless communication between real-time manufacturing and enterprise management systems. So next, before going into elements of automation, you will be learning about the basic concepts of industrial automation. So I told you about the levels. So here also you have here five different layers. So same thing, field level, control level, sorry, field level, control level, supervisory level, execution of planning level, and finally we have the enterprise level. Each particular layers work together for efficient data flow and control, and it is mainly used for decision making from the execution level. So, uh, so there are some other points which you have to see it along with the elements of automation. So first you have to consider sensors and controllers. So sensors are nothing but devices that collect data from the physical environment. And for example, such as we have temperature, pressure, speed, position, real-time feedback for the system, etc. And next we'll have controllers. So this element includes PLCs, and it controls the other process from the data from the sensors, and it sends commands to actuators to manage machine operations. Next we have actuators. So where we have mechanical devices like motors, valves, or other relays that receive signals from controllers, and it also performs physical actions. And next is the communication system. So these ensure seamless data exchange between the automated automation components, which allows sensors and controllers, actuators to communicate effectively. So next we'll move on to human machine interface. So this interface allows operators to interact with the automated system. So HMI also monitors processes, and it also makes some adjustments when necessary. So that can also be done using control panels and so on. So these are the types of automation. So first, you will be seeing about fixed or hard automation, and next you will be learning about programmable automation, and third you will be learning about flexible or soft automation, and fourth we will be calling that as integrated automation, and finally it is robotic process automation. So here these are the types of automation here. So listen here. So uh, in the level 1, 2 and 3, the automation represent different layers of automation in industrial processes. So each particular thing represents distinct functions and responsibilities, and we'll have some different functions, responsibilities, and examples for each particular level. For example, we can say, for example, if you take field level, this is considered to be the base level, which is focused on the physical equipment in the plant. So, for example, you can consider devices like sensors, actuators, and motors and valves. So, when you see the responsibility, it collects the real-time data from machines, and it controls the basic operations. So when you move on to control level, if you consider the functions, so in here in this level, it is responsible for real-time control of processes. So mainly it is done through PLCs and distributed control system. And for example, you can say PLCs can control machinery operations in a production line. So it can also ensure machine flows predefined sequences. So next we'll have the third level where we'll be seeing some functions like supervisory control and data acquisition systems, which is responsible for monitoring, controlling, and managing production processes. So here you will be seeing about SCADA systems, visualizing mission performance and enabling operators to control processes, and it enables MES managing production schedules and quality. So these are the types of automation. So next we'll move on to programmable logic controllers. So PLC stands for Programmable Logic Controller, which has invented in automobile manufacturing to provide flexible and easy programmable controller. So it was started in the year 1964 by Dick Morley. So when you consider programmable logic controller, it is a specialized digital computer employed in industrial settings for automation and control. So here, acting as the central brain of machinery and processes, PLC also receives input from sensors, process the data through the program logic, and it generate output signals to control devices like motors and valves. So they use programming language. Often you can use ladder logic, and it resembles some electrical relay diagrams. So here we can use this in very harsh industrial environments, and it also play a crucial role in automating tasks, and it also reduces manufacturing and energy. So this modular design allows scalability, making them versatile components in modern industrial systems. So if you see if you see where we can use programmable logic controllers, so it plays a vital role in industrial automation, efficiency managing machinery and processes. So they also receive data from sensors, and it is used for execution programmed logic, and it can control actuators, enhancing precision and reducing manual intervention. So their robust capabilities can be made to consider modern industrial settings, so which facilitates seamless control and automation for improved efficiency and reliability. We'll move on to some PLCs. So here it's considered to be a programming language where we can use often ladder logic resembling electrical delay diagrams and so on. So the industrial environments which plays a vital role in automating tasks and reducing manufacturing and energy. So here you will be seeing about streamlined operations. You can enhance their productivity, adapting to evolving production needs, and so on. So here in the when you consider the components of PLCs, there are six different types of components. So first we have processor, second we have memory, and third we have input device, fourth it's output device, next we have power supply and programming device. So if you see the description of each particular part, you will be able to understand what is the specific functions of each particular component. When you consider the CPU, so CPU, as you all know, CPU is the brain of a PLC system. So it is responsible for executing the control program stored in the memory. So it performs tasks such as data processing. It performs decision making and communication with other devices. So when you move on to memory, we can consider RAM and ROM. So PLCs have main type of memory. One is RAM and the other is ROM. So RAM is used for storing data and variables temporarily during the execution of the program. So ROM is used to store the operating system of a PLC and the user program. So the program typically consists of two ladder logic. So functional block diagrams can also be used here. So when you consider input device, so this device is responsible for interacting with the machines. Okay, so the instructor can also be used to access the external sensor switches and so on. So this part helps to take input and send output to the CPU to respond accordingly. So when you consider output device, uh, so this device is mainly responsible for interaction. So interaction with the endpoint external device like motors, valve or indicators can also be communicated. So it converts control signal from the PLC uh, to other devices which we can interpret. So considering the power supply, so it requires a stable power supply to run its program and it matches the voltage levels that need for a PLC components. So when you move on to programming device, so PLC is mainly considered as a programmable device. So we need a device where we can write code and we have to execute it just like a monitor and a keyboard. So these are the main components here. So here you will be learning about the structure of PLCs with block diagram. So there are four main parts in this PLC. So it gives the input and the output module. So it has controller and a power supply. So the first supply goes to the power supply machine, which is 220 volt AC. So and then it is later divided into three parts. So it is converted from AC current to DC current. So both of the two input and output takes 24V DC current and the main controller takes in 5V DC current. So the input takes signal from the sensor and other devices and it passes to the PLC main part. So when you consider the main controller, the controller sends the signal to the CPU and then it starts executing its program in compiler from the memory. So after all these process is over, the program creates an instruction signal which goes to the output module. So the output module receives type signal and it sends to the external device like motor, valve, etc. So which will execute the instruction by controlling the system according to the instruction. So this part can continue in a loop cycle. So for one cycle, this whole process is called the scan time of PLC. Uh, so so this part continues in a loop cycle So for one single cycle, this whole process is called a scan time of PLC. So here we have some modules. So we have different types of PLCs here. So the first we have compact PLC. The second type we have modular PLC. The third we have rack mount PLC. So first we'll be seeing about compact PLC. So compact PLCs are small size and we have limited number of input output pins. Okay. So these are designed for space in a critical factor and it control the requirements and it is very simple. So compact PLCs are often used in small scale control applications where the number of devices to be controlled and monitored is very much limited. So the examples include simple machines, standalone equipment or processes with minimal complexity. And next when you consider modular PLC, so it is designed with the modular architecture where you can consider CPU, power supply and input output modules. And we have separate components. When you consider this design, it's very simple and modular. So modular designed product or modular designed architecture provides the flexibility in the system configuration. So it also helps in making it easier to expand or modify the system. So based on the changing needs, we can make it very easier and we can expand or modify the system. So when you consider modular PLCs, which is suitable for applications, so that may grow or change over the time. So industries with the evolving control needs, such as manufacturing plants, they will be using all these production lines, and they can also expand all these production lines. So next we'll see what is rack mount PLC. So this is a type of high-end PLC, okay? So which is specifically designed for complex and demanding application. So it has a maximum number of input-output points, also called as rack mount PLCs, which is very modular and it can be easily expanded by adding additional modules to the rack. So when you consider this rack mount PLC, we have input output which is embedded in the compact PLC, and we have modular PLCs where we have the power supply, CPU, analog input, analog output, digital input, and digital output. Okay, so these are the types of PLCs. And when you consider the features of PLC, we have some features. So the features are digital and analog input output. So it's based on the scalability, communication interfaces, programming language, real-time monitoring, and mathematical functions. So it can also handle both digital and analog systems from the sensor, and other input device can allow a wide range of inputs. So when you consider features in scalability, many PLCs offer modulation in their setting up by expanding the input output number of CPUs to accommodate the changing requirements. So next in the communication interfaces, so here it supports various communication devices and protocols like Ethernet, Modbus, and devices like CPU monitor and control systems can everything be interfaced together. So moving on to programming language, so it allows different programming languages like ladder logic, structured text, function block diagram, and so on. So which is very helpful for the users. And moving on to the features, real-time monitoring. Here, PLCs can operate in real time. So by continuously scanning and processing input signals, it make rapid decisions and it can update output devices with minimum delay. So when you consider the mathematical functions, PLCs support mathematical functions and the calculations enables users to perform computations within the control program. So next we have application of PLC. So the manufacturing, automation, process control, water treatment and distributions, food, beverage and industry, HVAC systems, everything play a vital role with the PLC controller. So when you consider the scope of PLC in future, so it is expected to play a crucial role in Industry 4.0 revolution, so which focuses on the integration of digital technologies like IoT, cloud computing, AI in industrial automation, and so on. So we see adoption of protocols like OPC UA for standardized communication and intercooperation of edge computing for faster data processing. So programmable logic controller programming can be done with the help of ladder diagram or ladder logic. So here in the ladder logic, you will be having output. You have some rails. You specify switch rungs etc. here. So when you consider programming in ladder logic, it represents the control logic and it depicts operations such as comparison of timers with inputs and outputs connected by lines. So we have a function block where you will be having motor 1, motor 2 and relay. So we have a regular flow of these particular functions which can be represented in the function block diagram. So next we'll move on to real-time control system. So real-time control systems are widely used in various fields. So it includes manufacturing field, robotics field, and it used in aerospace and defense and so on. So when you consider a real-time monitoring, a real-time control system in robotics, it helps in enabling robot to interact with the environment in real time, such as in assembly lines or in automation vehicles. So when you consider aerospace and defense for applications like flight control system and missile guidance, timing is very critical. So you can consider real-time control systems for these type of applications. So next we'll go for the definition and characteristics of real-time systems. So when you consider here, so the characteristics of real-time system are it is determinism and it is based on timeliness and reliability. So when you consider all the three characteristics features, the system behaves predictably under predefined conditions and it ensures consistent and reliable responses. So when you consider timeliness, task must be completed within a given deadline, so which is crucial in scenarios where delays could lead to failure or safety hazards. So when you move on to the third reliability, these systems must function correctly over long period without failures, especially in safety critical environment. So real-time control system is designed to respond to inputs or changes in the environment with strict timing constraints, ensuring reliable and timely operation in various applications. So when you consider the definition, so real-time control system is computing system that respond to inputs to changes in the environment within a specified time constraint. So next we'll move on to the other topics. So here you have been learned about the real-time systems and PLCs. So as of now, the second part is over. So we'll be continuing with the other parts in the next video. Thank you all.